I am going to explain about uniform distribution example. Uniform distribution means if x is a random variable and the data is varying uniformly. For example, so if we take one company data, so just assumption here, and this x is a random variable and the data is varying like this. The first day the mobile designing company is designing 100 mobiles, and the second day they are designed 100 mobiles, and the third day again they are designed, just assumption, 100 mobiles. So means here the data is uniformly distributing from 1 to 3. So this is an, then what is an average density function? Average density function f of x is equal 1 by b minus a from a less than or equal x less than or equal b. So this is already proved in the previous class, that is f of x is equal 1 by b minus a for uniform distribution. So here a and b are the limits. We will go with examples. In the university exam, maximum he is asking, he will give the limits, then he is asking find the density function. If the data is uniformly distributed from the limits, then what is find the uniform density function. So you will go with example. This is coming to the application. We are already discussed in round of process. This is used to take the round of values and communication systems maximum in a sampling. So they will go for a round of values. If any up and downs sample values are there, so they will take it as some round of value. And coming to the example, you can see this, if the data is uniformly distributed from 0 to 5, then find uh, uniform density function. So here 0 to 5 means a is 0 and b is 5. Then what is an density function? Uniform density function. Uniform density function. Uniform density if the data is uniformly distributed. F of x is equal 1 by b minus a. B minus a. So therefore 1 by b value is 5 minus a means 0 is equal 1 by 5 is equal f of x. So this is an uniform density function. And again one more is asking the limits from the probability from second part, probability from 1 to 5 f of x dx. So you are asking this, so therefore that is equal 1 to 5 f of x value we already calculated, that is 1 by 5 dx. So take it 1 by 5 outside, and 1 integration is x of 1 to 5 is equal, substitute the limits for, that is 5 minus 1 by 5 is equal 4 by 5 is equal 4 by 5. So this is the way to calculate the uniform density functions. And one more example, you will do it anyhow. So if the data is uniformly distributed from minus a to a, then find the probability from minus 1 to 1. So first we need to calculate the f of x. So if the data is uniformly distributed, then the density function equal to 1 by b minus a. Here this is a and this is b. So therefore that is equal, b value is a value is minus of minus a, minus a. So that is equal 1 by 2a. This is equal uniform density function f of x density function. Then we need to, they are asking the probability from minus 1 to 1 f of x dx. F of x dx is equal minus 1 to 1. F of x means 1 by 2a. We are calculated just now dx. So therefore 1 by 2a is a constant. Then one integration is x of minus 1 to 1. Substitute the limit, upper limit minus, lower limit minus of minus 1 plus 1 by 2a is equal 2 by 2a is equal 1 by a. Like this, we can calculate the uniform density functions as well as the probabilities. Thank you.